Alright, draft science again. Number 13. I think I probably will start over from the beginning again eventually, and just through each version try to get more and more concise, and make the diagrams more coherent, or easy to understand, perfect. The images. I think the swarming fish idea is a really easy to understand idea, that you have this complexity, and this complexity has to drift when there's movement. It maintains, and it also eats more space in a direction. So I keep using this word eat space, and I guess that's where I want an effect. The difference between what I'm saying and what Einstein is saying is he's saying space is changing, and this would account for the extra spaces, so to speak, the shortening of distances in terms of Planck constants within a distance. So he's basically saying the squares get smaller or the squares get bigger. Like a checkerboard where the squares get bigger and smaller will give you the illusion of less distance being traveled on the smaller squares and more distance being traveled on the larger squares. And what I'm saying is more of a, have a vision of a transparency of sorts, where you can just slide the board from underneath the checkers. And as you slide the board in a direction, they have to maintain where they were. So they have to get back to the square they were on, so to speak. And that's going to take them time. They're going to have to wait for a Planck constant of time to be able to make that jump. And that jump in that direction is going to steal some of their motion in the other directions they were moving. So if a checker was going this way, the board slides. Now it has to waste a Planck constant of time to go sideways with the slide and then go back forward again. So I think that could be understood, that if this slide is happening just a little bit, like you get 1,000 moves in your normal direction and 1 move in the sideways direction, that it would be disruptive but not catastrophic to function. And that's sort of the proportions we're talking about when we're talking about the speed of light being 186 miles a second. That's related to the Planck constant. That's flying on the Planck constant, that speed. And so you can imagine that every other motion is happening very slowly. So in the time it took me to move my hand 1 foot, the universe did 1 billion other things. Okay, 1 billion at least, maybe more, but it doesn't matter. I mean, a tremendous number of processes took place in that 1 second on the universe's scale. And I guess that's what's another point to make here, is that we're talking about the universe, and it has the real universe is on that Planck constant scale, on that tiny grain. It's a very fine frame rate, a very high frame rate if you want to call it that. But more importantly, it's like the pixels, there's like a zillion or 1 billion pixels in one little circle. It's the grain. It's not just ultra high definition. Okay, it's billion vision or zillion vision in terms of how much resolution you can get to get all the way to where the universe is really happening, where the checkerboard really exists. So again, the difference between what I'm saying and what Einstein is saying, I'm just saying what accounts for the illusion of bigger squares and smaller squares is the movement. The movement consumes time because it consumes distance. Things must move sideways to do whatever else they're doing. They must move in some other direction also. Some percentage of their time has to be wasted going sideways. So it's like you doing anything. You could be walking from one place to another, and somebody gives you a rule that says, well, every 10 steps you have to take 1 step sideways, and then go forward. And then you have to take one step sideways the other way, and then go forward. And then one step sideways the other way, and then go forward. You can get the idea that to travel the distance, you're not going to be able to do it in the same amount of time because you've wasted time taking those sideways steps. Yeah. So again, a lot of this math is going to fit with at least general relativity, in the sense that he's just using a different variable to describe the effects of sideways motion, which is the distortion of space. But again, it's movement of matter that creates the necessity for there to be a consumption of space in a direction. It is drifting the school of fish. So it's still a, Alright, and so the other thing I wanted to get to, I'll read the comments and I can probably get to it through the comments. Again, I would argue that some of this is intuitively understandable. I went looking for the speed of electrons, in orbitals, just to see if I can find some kind of information, give you some indication of what has to be explained in this space dilation thing. And part of what we know is that electrons communicate to the world, from their perspective, with light. They're always emitting photons all the time, interacting between the nucleus and the electrons, all this kind of stuff. At least there's some theory that that's what's going on. Now those photons, again, are in the same position on the checkerboard. So they're going to have to travel more distance to get where they're going because of this lateral movement, whatever lateral movement there is, whatever direction it is going to lengthen whatever distance they were traversing, which again has this illusion of time dilation, but it's really distance dilation. It's really just the fact that you're creating more distance by moving. Moving obliges you to consume space. And again, it's back to this argument, but that's what's happening here. We're consuming qubits of space. That's what matter does. That's what energy does. That's what light does. That's what photons do. And the energy in matter is consuming space. And when you move the collective, it's going to have to consume more space. Yeah, there was some other point I wanted to make, but yeah, back to the speed argument. So again, we could, they could see it intuitively if you look at it. And especially, I guess, in radioactive elements, there's very wide orbitals that are traveling very fast, close to the speed of light, the electrons. Closer, anyway. 400 meters per second. I don't know what that translates, but regardless, fast. And so they're already moving very fast. So again, you'd have to account for how they could have that speed and then move very fast in some other direction. So they have to go in this circle and then also go that way very fast, and you'd say, there's no way they could do that because they'd be going faster than the speed of light. And that's like one of the things we should be able to agree on is the constancy of the speed of light. If light takes longer to do something, it's because it's traveled more distance. If light takes longer to do something, it's because it has traveled more distance. Wow, I don't think that can be argued with. So anyway, I'll read these life is futile guy comments. As it relates to Einstein general relativity, and yeah, I'll just point out my general knowledge of what's being argued here. Quote from 21 Minutes. Special relativity and general relativity predicted something, question mark. You says you. Alright, so I'm just making this argument that these predictions are kind of a... Physicists always say this stuff about predictions, but it's not really that something predicted something, it's that they came up with a formula that resolves something. And general relativity, I think, falls into that category on a couple of accounts. Both theories made massive predictions, so they're always saying shit like that, which were immediately and later verified. A well-known one being the near-perfect prediction of Mercury's orbit around the Sun by general relativity. That was known before Einstein introduced his paper. I think it's actually in his paper. So it'd be stupid to say it predicted it when it accounted for it. Okay, so this orbit thing is sort of an interesting subject. So maybe I'll waste a piece of paper doing a little bit of explanation. So there's these ellipses that planets are in around the sun. So they all travel. I mean, this is an exaggeration, it's got to be said. They're almost perfect circles. They're just a little bit off here and there. But anyway, and what accounts for the fact that the planets are in these ellipses is mostly the gravity of the other planets. So the other planets are all have a gravitational impact, you know, especially when you get to these big blobby ones. And this wobbles the ellipse by a certain percentage. Now, there's two things that when Newton did his calculations, two things he didn't know. The first was that, see this one, I love the way this one works out to my advantage anyway. Gravity moves at the speed of light. So see, Newton kind of thought it was all instantaneous. He thought the gravity that from this body would instantaneously affect the other bodies, so that there was no delay in time for the reach of gravity. But the fact is, the shadow does take time. There, 10 minutes, 8 minutes, depending on which planet it is. And I don't know whether in the overall calculation that's significant or not, because the pluses would be the minuses and all that kind of stuff. But it's just a fact that in Einstein's new formula from general relativity, he would have the constant of the speed of light in there, representing the fact that there is a time delay. The Planck constant would be part of his calculations, recognizing the fact that there is this, it takes time for gravity to get somewhere. And remember what gravity is. Gravity is the shadow. So it takes time for the shadow to be cast when the shadow is being cast over long distances. And the shorter the distance, the less time, quite obviously. The other thing that Einstein's the whole general relativity sort of dealt with was something we already know about, which is, light will travel around impediments. So we can already see that with just simple impediments. You can put a needle in front of I can put this pen in front of you, and this pen will become transparent in a sense from certain focuses, because the light will go right around it. It will be deflected by it somehow. And so this is this surface argument. It only happens around the surface. It doesn't happen out here, it doesn't happen here, it doesn't happen here, but it does happen on the surface. And gravity's doing the same thing. And so that's somewhere in Einstein's, where Einstein is doing something different than Newton was doing, is in that recognition that there is this lensing effect, and around surfaces. And so that's part of gravity's also, let's say, lensing, which is another argument to be made. That again, if we have this force that is coming in all directions, just a pressure that is, it's not a wave in one direction or a wave, it's just things moving in all kinds of, directions, coming from all kinds of directions. This infinite pressure, that's another argument to be made, is this pressure has to be pretty strong, and it's only that gravity is blocking some percentage of the pressure, but it would be a slight percentage. Most of the pressure goes through, and it's only the change in the pressure that creates this effect of gravity. So what would also be argued is that close bodies, when this lensing takes place, okay, it would be very different than the effects, it'd be stronger effects than the further you get away. So the further you are from the gravitational body, the less strong any effects from this bending of the gravitational force on this thing. So I mean, it's like the thing that creating the gravity, these pressure photons, are also affected by the gravity. So some of these photons will be bent by the very force they are creating. The very there's a whole bunch of theory. Newton did this too. I mean, Newton was an incredibly clever person. The effects of shadows, and the imperfectness of their periphery. So that's a whole nother subject, though, I don't want to get into. So anyway, that's a sort of an explanation. So there's two counter proofs to general relativity that they sort of built into it when they wrote it. So those are two predictions that, frankly, it was written recognizing. So, I mean, you can't really call it a prediction when your formula essentially was written with those things in mind, so to speak. A single piece of, a well-known being the near-perfect prediction of Mercury's orbit around the Sun by general relativity. So again, just recognize. So let's say the planets account for 500 of this deviation, 500 pieces of it. General relativity resolves 42 pieces of it. Okay, so it's just just creating 40. What was that? 1/20th of the. No, it's less than that. But anyway, it doesn't matter. So we're just talking about a little bit of an error, and the idea that there would be effect changes as you get closer to a gravitational body's surface, and that surfaces have significance. Again, I can't go into the details of what that significance is or how that significance is expressed, but the fact that light is bent close to the surface of a planet is kind of as understandable as the idea of light bending around objects. Okay, a single piece of counter evidence would be a single piece of counter evidence would be all it would take to disprove either theory. Yeah, well, counter evidence, like saying what? That he's wrong to account for gravity moving at the speed of light, or that he was wrong to build into it an acknowledgement of surface irregularities or something in gravity. No, I don't think either one of those two things are wrong. I'm not disputing those two things. I'm disputing that space is dilating. I'm arguing that distance is increasing when you move, because you have to eat the space. You actually have to consume it. When you're moving, you consume space. You have to eat the space, like a wheel has to turn on the road. You can't just... You have to actually eat the space. If you want to get from here to here, you have to ride on the space. And that's what's creating the extra distance, which is creating the extra time it takes to get from here to there. Alright. But there is no known evidence. Well, I don't even know what that means entirely. There's no known evidence. Like I said, why would somebody dispute things that are worth including? It's again the interpretation of the cause that I'm arguing with. The closest being that quantum mechanics and general relativity are not compatible, meaning that there must be some underlying more fundamental theory which breaks down into both QM. Well, quantum mechanics is it isn't a coherent statement. Quantum mechanics. I mean, really, it's not an explicit statement, so it shouldn't be compatible with anything because it's so inexplicit. I mean, it's just acknowledging changes in electrons. That electrons have basically state changes, and that instead of being specific about those state changes, we'll just ambiguously throw them in a pile and say this is their area of influence, something like that. GR are different size scales. Well, none of, like I said, if you're going to talk about the rules of physics or the laws of physics, there is no size scales, in my opinion. Your rules have to be rules about what physically is happening to things interacting in the finest grain. The finest grain is the only grain. That is the true universe. I mean, if you're going to just say that block elements, like a human with zillions and zillions of atomic particles, is the scale, and you're going to ignore the fact that it's zillions of particles that make it up, zillions of moving things, then you're falling way short of physics. So I think the idea that we are prejudiced to our size scale. Another way of looking at this is we are moving incredibly slowly. Everything I'm doing right now is so fucking slow compared to the speed of light. Right? Compared to the grain of the universe, I am like, you know, billions of years later. You know, there's like, you know, it's this yeah, I'm just so, it's, you know, like I'm just saying that you have to understand that everything you're doing, when this pen spins, this is 500 million years on the scale of the Planck constant. 500 million years just went by. 500 million years. I mean, it's that much slower. Alright. Here we go. Where was I? The closest thing, blah blah, quantum mechanics. Okay, string theory does this, but the problem is that there were 5 separate versions. Now the problem is that string theory is just loopity-doopity-doppity-doo. It's a pile of crap. That's the problem with string theory. There's no pre-written paths. It is clump physics. Strings are another, you know, it's like the other guy with his rope theory. Let's create a whole huge infrastructure that everything's traveling on. You know, so you have this whole, like, everything gets into subways to get from here to there. So it's like a, you know, so you have this huge mechanical system that somehow is controlling photons, that you'd have to explain, like, well, who built the subway that the photons are traveling on? I mean, it's just, no, it doesn't go anywhere. These, however, were later shown to be consistent under M theory. Yeah, well, whatever, I'm not getting into that loop-de-doo. Alright, next comment, same, you know, there's a whole bunch of this shit. I would like to add, you know, I haven't read these, so this, you know, most of this. I would, so, you know, if I fuck up a word, sorry. I would also like to add that so far what you have created is a list of conjectures, not a scientific theory. Well, you know, you want to put these things in different labels. I guess it depends on whether you're right or wrong. It depends on what you're doing, right? It's conjecture if you might be wrong. And it's a theory if you're, oh shit, that's so fucking accurate. So I guess, you know, that these are words you can just play with, right? And I guess I would argue that I think this explanation fills so many voids of logical continuity that it can be called legitimately called a theory. And I think once people start thinking about it, it won't be long before it's like evolution. Like, oh, that's just so obvious an answer. You have two choices, God or evolution. Oh, fuck. Evolution is just brilliant by comparison. And what I'm saying is, I think this is brilliant by comparison. This is the straighter line, the Occam razor's answer. A key requirement for something to be a scientific theory is that it makes testable predictions. Well, clearly, I'm claiming that we have an absolute velocity. And, yeah, I think if somebody looks for that, they can find it. There are tests you could do. See, the trick is we don't have a light clock. The perfect clock would be a light clock, okay, that just somehow traps light in a mechanism where it doesn't interact with electrons. So, like, fiber optics would be really cool, but no, light doesn't just go through fiber optics, it interacts with the fiber optics, so there is friction, so to speak, in fiber optics. There is, the light is constantly interacting with electrons, and so it would be the electrons are going to have the motion, and so they're going to distort they're going to time dilate your light clock. So the problem with clocks is clocks are all dependent on the swarm of the fish. All clocks are like the fish are in movement, and so if you move the clock breaks. I mean, in the sense that the clock's not going to take, it's going to take longer for it to do the hands to go around the face of the clock. It's just a fact. All these clocks will break when you move them, especially clocks dependent on radioactive output of any kind, because those elements, those atoms, are highly unstable, and any amount of movement is going to screw them up. But anyway, key requirement for something to be okay, predict. Yeah, well, again, I think there are some predictions built into this. I think it's going to predict the function of magnetism, and I think it's going to tie gravity and magnetism together. But yeah, I would predict, on the quantum level, that if you aim light, okay, at the slits, if you actually aim it before if you aim the light at the slits, or even electrons, as I understand it, they don't even do the electron experiment on the two-slit experiment. They use a crystal, which I think kind of breaks the whole idea. But anyway, if you actually do the experiment by aiming them ahead of time, aiming the photons at the slits, and just do it mathematically, both sides of the slits, the same number of photons, blah, 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 and that you can artificially create by aiming, and you'll know exactly what slit they went through. I'm predicting you'll get your bar pattern with aimed photons. That's a prediction I'll make. So I'll come up with a list of predictions, because there's some things I can predict. I'll predict that you're never going the speed of light, and I'll predict you're never even going close to the speed of light. That I'll predict for you. A key requirement, okay, currently it is not clear how we would use your conjectures to make testable predictions. Well, like I said, I think I'm saying there's absolute momentum, there's absolute inertia in space, and that we should be able to detect that absoluteness. Are even consistent with both quantum mechanics and with general relativity. What? And there isn't a mathematical framework in place which shows that the conjectures are even consistent with what is both quantum mechanics and general relativity, which is essentially what you need to show. Well, again, you can't even show how quantum mechanics and general relativity are compatible with each other, and you're forcing me to be compatible with both. I'm saying I can easily be compatible with quantum mechanics, because quantum mechanics doesn't say anything very interesting. It's this vague replacement error code kind of, well, we have a probabilistic entity and we'll move that through math. Well, gee, okay, who's disputing that you have a probabilistic, that outcomes are probabilistic? I'm not disputing that. I'm saying they're explicit, and that our senses can only detect the probabilisticness. I can only predict the probabilisticness. If I go to Las Vegas, all I'm going to have is probability when I roll dice. But we know the dice are going to be mechanically rolled, and it's going to be a mechanical outcome. And there's no, it's just my ignorance that prevents me from winning at Las Vegas, correct? My ignorance of the exact physics. I can't see all the movement when they shuffle the cards. I can't follow along. And all quantum mechanics is saying is let's not even try to follow along. Let's just go with probabilities. Well, fine, I can be compatible with that. And as I already have explained, electrons, I think, already do fix quantum mechanics, as long as you understand that it's the complexity of electrons that are changing the dynamic. All right, I'll be back. Okay, back. So continuing somewhere close. You seem to be straying dangerously close to saying that QM and GR aren't correct. Well, quantum mechanics isn't saying anything, so obviously I'm saying that all the crap about quantum mechanics where they say you can't ever know a photon's position, that you can't know it, that it's in some hyperspace, and that it doesn't materialize until it has a concluding event, or whatever the bullshit is. Yeah, I think that's a crock of shit. Okay, so if you're going to call that quantum mechanics, yeah, I think that's absolute nonsense. Yeah, it's a physical universe, okay? The laws are rigid, the physics is rigid, there's no hyperspace bullshit. And then general relativity, again, I'm saying that it's just been misidentified, that there is no time dimension, there is no distant dimension. These aren't real dimensions. I mean, distance is something that has to be, it's Planck distance. And if you're going to move something, it has to travel that distance. And again, I'm arguing that I'm explaining things like inertia. I'm explaining why things have inertia. Okay, it's because they are occupied in the process of eating space. And I'm explaining why having that velocity slows down the metabolism of the matter. So from the matter's perspective, yes, the world's slowing down because its clocks are all slowing. Everything it's doing, it's like, to move my hand like this, all of a sudden it took 10% longer because my hand had to go that way. I mean, that way. So it took 10% longer. Obviously, I'm going to think the world has slowed down, but the world hasn't, or sped up. I've slowed down because I can't do what I was just doing because now I'm spending 10% of my time going that way. This isn't that complicated. So of course I'm challenging the assumption. Okay, you had to look. Einstein had a choice. He could say matter changes, or he could say space changes, and he picked the wrong one. The math is generally speaking correct. It's just that he's chosen the wrong thing causing it, and that will have effects. Like when it comes to dilation of length, and where they're arguing that, like in black holes, you get stretched because of the difference in the gravity. I think all that's crap. None of that happens. So I mean, I am contesting pieces of it, but I'm not contesting the entire thing. I'm just saying that Einstein's gravity well is pointed the wrong way. Okay, it's not. You don't fall into gravity. You're not falling. You're being pushed. I mean, again, we're talking about the difference between thinking of it as a force of attraction and seeing it as a force of repulsion. It's like understanding that airplanes are pushed up. Okay, they're not sucked up. Well, I guess they could be. Technically, it could be called sucked up. But the point is that you're not understanding airplanes if you don't recognize. Well, let's not get into the airplane thing because that'll just cause trouble with the Australian kooks. There's some other thing that there's an analogy for it, but I'm just saying it's just a misidentification of the cause, not an argument about effects. And by this I mean that they are backed up with decades. Well, here we go. Aren't correct, but these are well-established scientific theories. Well, again, well-established by what notions? Somebody could say that it was a well-established theory that things evolve by will. The giraffe willed its neck to be longer. And that would be incorrect. And then you get into some punctuated equilibrium argument. You get into some argument about inbreeding and how that creates more mutations and blah, blah, blah. And there's a better explanation. I'm saying that these things are not... Quantum mechanics is shit as an explanation of anything, and general relativity has misidentified the cause. And by this I mean that they are backed up with decades of research, and every time they are shown to be consistent with what is observed. Every time. Again, I don't think they're consistent with the observed fact that electrons are moving, and you have to account for how you're going to move the electrons in matter some super speed besides the movement they're already moving. Yeah, without going faster than the speed of light. I don't know what else there. I could. I'm just saying that. Yeah, I think this will be dissected. I think this can be dissected, and I can demonstrate my answer to be more consistent with evidence. The onus is on you to show consistency mathematically. Well, again, I don't have to because that math has already been written. I don't have to redo Newton, and if I did redo Newton, all I'd do is do exactly what Einstein did, which is add gravity. Add the speed of light to gravity, and the recognition of you know, the fact that photons can be deflected, changed in their path, depending on the pressure gradient that they're passing through. Call it a pressure gradient, or a gravity well, as Einstein would say. I would say pressure gradient. The onus is on you to show it isn't on us to point out flaws in your conjectures. Well, I don't know. I mean, it works both ways, fuckhead, in my opinion. So you can have that attitude all you want. I'm saying you're wrong. I think I can probably demonstrate some paradoxes that are created by the reality you've accepted, and I think I have a better explanation that's not vulnerable to those paradoxes. Alright, and thirdly, I see you have likened yourself to Einstein, the fact that you both rely on thought experiments to derive a set of conjectures about the universe. I don't know. Again, I'm just saying, when Einstein said, okay, look, matter converts to energy, and it appears to convert to energy entirely. It just seems like, fuck, why didn't anybody, even Einstein, why didn't Einstein take that seriously? Okay? M equals E. You don't even need the constant. I should point out here that Einstein's thought experiments concerning special relativity were not that great a leap from the understanding at that point in time. Well, again, like the elevator examples, the top of the elevator versus the bottom elevator, the clock in those two positions, you know, those kinds of perceptions of gravity, in my opinion, are going to be flawed, in the sense that the way gravity happens, the way it moves through us, is from outside to inside. That's where the convergence is coming from. The way it affects matter seems quite obvious that it affects every single atom in the matter. So gravity has a high density. It has a high hitting the target rate. So the function of gravity affects every single atom as it moves through something. It just affects it in a proportional to the amount of mass, but it's a complete shadow. Every atom casts a shadow by gravity. So the grain of gravity, you know, the grain of the sand pushing, is so fine that nothing can resist the flow of the sand. Something like that. Maxwell had already established that the speed of light must be a constant. Yeah, well, I'm just saying that just seems so, I mean, yeah, that was, you know, they knew that a long time ago, but they didn't understand, well, they knew it was constant, they didn't know exactly how fast it was, I suppose. Einstein then postulated that it was a constant in all inertial frames. Well, again, there is no inertial frame. Your inertial frame only exists inside of you, and quite obviously, again, if I oblige light, you know, here's an electron, and say here's a proton, and if I oblige light, you know, it's light, a little beam of light, a light corpuscle, as Feynman would say, is going to move from here to here. Well, the fact is, if this thing is moving this direction, okay, then it's going to have to move extra space. Even though it's light, it's going to have to move that extra space. So it's going to be moving slower than the speed of light inside the thing, in the sense that what took this much time before is going to take this much time now, because it has to move that extra distance. And so although the light's moving the same speed, clearly it's got to move more distance. So, I mean, it's kind of silly to say that it's a constant in all frames, when, no, in some frames, light has to travel more distance. It has to. I mean, if you're moving, the functions of all the functions inside your nuclear structure are going to have to do extra work. If they're doing some certain thing now, and I move you 50 miles an hour in a direction, Well, I'm going to oblige all the work they're doing to be, I'm adding a little more work. They're going to have to do this 50-mile-an-hour thing also, and the light's going to have to do it also. But clearly, as soon as the light leaves that structure, that movement, and goes back to space, when it's in the environment of space, okay, there's no extra distance anymore. There's none of that stuff is going to have any effect on the light itself. All right. I mean, we can get into redshift and all that kind of stuff, but that's a frequency change, not a speed of light change. At the time, it was a, let's see, Einstein, at the time it was a race to derive a theory which showed Maxwell's electromagnetism. See, I just don't, this electromagnetism thing is a little bit tricky too, to be consistent with Newton's laws of motion in absolute space and time. Maxwell had already established that the speed of light must be a constant. Einstein then postulated that it was a constant in all inertial frames, meaning no absolute time and space. Well, that's not even what Einstein is saying. There is absolute, in the sense that it's the only place this dilation is taking place is in the frame, and it doesn't happen in the communication. So if I was to communicate with somebody using light that was in an inertial frame of distortion, clearly the light would obey the same rules, but clearly once it got in the frame, it's not obeying the same rules, and then it's going to have to eat more distance, which is going to give it which is going to slow down its function. And so there's not going to be any immediate response. I'm going to say hello, and the other person isn't going to hear hello because their metabolism is so slow that it's going to take an awful long time for that hello to resolve itself, and therefore their response back to me is going to have no coherency to the light that I sent to them, which was perfectly valid light. Anyway, I think you could probably get into a paradox right there in terms of, well, again, it's just distance. So again, all you're doing is adding distance that the light has to travel, meaning no absolute time and space. He did this via a thought experiment considering the speed of light transfer of information from different inertial frames, and then derived all the mathematics which fell out of that conjecture. Well, again, these frames are just places where there's more space being eaten. The light has to travel bigger distances, so it's just not true to say something like, well, from the light's perspective, this is the shortest distance. Well, yeah, of course it is from the light's perspective, but it's known that there's extra spaces now in front of the light. The light has to travel more distance. It's not the shortest distance. It's a longer distance because the whole frame of the checkerboard is being moved. Alright. Inertial frames, and derived the mathematics which fell out of that conjecture. It was then shown to be consistent with the experimental data and unified previous theories by neglecting the concept of absolute space and time. Negating? Yeah, I guess that's what it's put. Well, it doesn't matter. Again, I don't think there's any problem with having absolute space and time as long as you understand that the checkerboard doesn't change. How many spaces on the board you move changes. Poincare was close to on his heels, though, and published a similar paper shortly afterwards. Einstein took most of the credit, though. My point here being that Einstein was fully up to date with current scientific theories and mathematical models, and then made one additional conjecture from the thought experiment which revolutionized physics. Well, again, I think it's, like I said, he had a choice. He could choose matter changes or he could choose space changes, and I think he just got it wrong. The matter is changed by movement. You change the structure of the matter. When you move the fish, the school of fish is obliged to drift. The fish have to consume more space to do it. They have to move more squares on the checkerboard. So whatever squares they're moving right now, like I said, just think of it as a checkerboard. The checkers are moving, and now they have to go somewhere on the board. Well, they have to eat those more spaces. They have to actually step on them, and it will consume time. Jesus Christ. So again, it's the effect is very similar to Einstein in most respects. It's the cause is entirely different, and I think understanding the cause correctly will make more, it's better science, because it's the truth. Getting it right is going to help, not hurt. And they currently have a wrong perception of what's getting changed. The obligations of the matter are what's changing, not space. Okay. So I think that's probably enough. Let's see. Yeah, so I just wanted to make that slowness point. Yeah, I think that's enough for this episode. So, you know, I'm going to try to redo the magnetism video, because I just didn't do that very well. But I mean, you know, the idea that actually the north and south pole are actually probably compressed into each other. It's actually a gravitational mechanisms actually holding them together. But the idea that one creates what the other is sensitive to, you know, converts. That's another word I got to be more explicit about, is the gravity is a conversion of energy, not an absorption of energy. So that's another point I've got to make. And this whole idea of the, you know, the infiniteness of the pressure. I mean, how big a material object can you have? I mean, how dense can matter get? So m versus the volume. So how much, what volume can you shove mass into? And at what volume does all the pressure get absorbed? Where you actually exhaust the pressure in a direction. Where halfway through the mass is so dense that halfway through it all of the gravitational photons are consumed, and so it can acquire no more gravity. It cannot make something move faster towards it, because, you know, the pressure gradient cannot be increased any further, because you have actually created a complete shadow. Again, in my model of gravity, gravity is a shadow, but it's not a black shadow. It's a shadow of gray. So it doesn't block out all pressure, it just blocks out a percentage of the pressure. And it's that percentage that is contrary? No, there's a better word. The opposite pressure is increased relatively, and it's the relative change that matters, not an absolute change. So it's not blocking out all the gravity, it's just blocking out a high enough percentage to make the pressure on the other side strong enough to push it. It's a pressure gradient. But you know, what is the absolutes on that? It'd be an interesting thought experiment. Anyway, till next time, and such.